This is part 3 of estimating existing sprinkler design. Part 1 covered sketching a system. Part 2 covered the history of NFPA 13. This part 3 will cover estimating a pipe schedule system. For those who have some background on sprinkler design, you should be able to estimate a pipe schedule system after the completion of this video. Disclaimer, this is for entertainment and educational purposes only. These are estimates. You don't make any final decisions and you don't make any changes to a system without a full set of hydraulic calculations. Always be aware that this is an estimate only. In the prior video, I did not provide a full table of ordinary hazard pipe schedule layout, just the branch lines. And here is a full table with the 2-3-5 system, the 2 to 1 inch, the 3 to the inch and a quarter. And you can see there's 65 sprinklers would be fed by a 3.5 inch line, for instance. Were you able to find it? You'll notice that I have table 65332, and I pulled that from an earlier NFPA 13. The actual table for the 2022 NFPA 13 is 28.5.3.4. The only reason I pulled and used this earlier table was that it was flat and I could get a good picture of it, which I couldn't with the voluminous size of the of 13 and how curved the picture was. It just didn't show right. But that is the ordinary hazard pipe schedule system. You can see that 4-inch has 100 sprinkler heads. So you can use that if you know that it's a pipe schedule system to lay out a system and pretty easily determine that if you've got 10 branches with 8 lines, 10 branches with 8 heads, that's 80 heads. It's got to be fed by a 4-inch line, which is up to 100 sprinkler heads. Here is the extra hazard pipe schedule system. It's pulled from the annex of NFPA 13 2022 edition 28.5.4, and that's the 125 system that we spoke about. You can see the difference. If you recall, there would be 4-inch provided fed to 100 heads, and in this case feeds to 55 heads. You can see that it's a much more robust system. Were you able to find all that? Let me know. So what I would like you to do is do a search for AXA XL PRC 14.1.10, and there'll be a number of docs that come up. The one that you're looking for might be the 3rd, 4th, or 5th. Will be estimating fire protection water demands. This is the AXA is the old an outshoot of the old IRI guidelines, which were really excellent documents. We're going to use this document. It's only 8 pages long. PDF it and print it off. We'll be using it for this video. On page 5 of that AXA document, you will see table 1. The uppermost portion has a number of boxes that we'll go through here. Table 1, wet pipe schedule, wet pipe system. If you don't know the difference between wet and dry pipe, this may not be the video for you, but if you have some understanding, it'll go a lot easier. So what it's doing here is it's going to provide us with the pressure and the water required to meet a certain design for an occupancy. Let's just go through this. So starting on the left-hand side, it says spacing, line, head, and density. We'll ignore this density for a minute because I'll be covering that in an upcoming presentation. Line spacing is basically branch spacing. the upper left hand, it's 8 feet. Between branches and head spacing is, in that case, be 12.5. And then you can see moving across, we have a side fed system and a center fed system. If you recall, the center fed system had a cross main that ran down the middle with branches on either side, and a side fed had a cross main with branches running on one side. And then it says 6 heads, 8 head, 10 head, and that's just the number of heads on a branch. And of course, you see below that says ordinary hazard pipe schedule. That's our 235 system. And what we expect is a K 5.6 head. Ignore that 3,000 foot area of application. We'll come back to that in a little bit. So in all those boxes there, if you have a certain line spacing, a certain head spacing, with the certain system configuration, with the number of heads on a branch, you will need, looking at that upper right-hand corner, for a 0.12 over 3,000 system, 632 GPM at 30 PSI. I'll explain that in more detail in the next presentation, but just know that this information allows you to start to make decisions about the adequacy of the sprinkler system. On that same page is the 123 system with the 3/4 inch end lines that we talked about, the 1905 to 1940 system. Again, the same thing, K 5.6 head, half inch. It's what we expect to see in these older systems. And there's no difference than the above with the line, head spacing, density, and those numbers providing you with some sense of what the water and pressure requirement will be to meet the adequacy of an occupancy. And we wouldn't be without the 125 system that we talked about earlier in the presentation. It's a beefier, stronger, more robust system. Same columns, same rows, same philosophy here of providing a water supply and a pressure to meet an occupancy adequacy requirement. So there's no difference in any of these boxes that we're looking at. What we're looking at is where the table ends. So you'll see that there's an arrow and it says 640 at 27. So what it's saying is that those numbers provide water to those sprinklers that are within that dashed area. Now I'll explain in some of the upcoming presentations what that area of demand within that cross-section area means, and we'll get into the whole concept of density. But right now, know that the numbers in the box do not represent the sprinkler design, the sprinkler demand for the entire system, but represent a number at the point of the design area, and we'll explain that in more detail later. Here's an example that they show in that document. A machine shop, wet system, ordinary hazard pipe schedule, boom, those are all the pieces of information we'll need. 8 head branch line, remember that they had 6, 8, and 10 head branch lines. Spacing's 12 feet between branches, 10 feet between sprinklers. The elevation from the floor is 18 feet, and the riser is 200 feet away from the most distant area. We haven't covered that. We're going to do that on the next presentation. So we determined that the machine shop is an ordinary hazard group 2 system. How do we know that? I'll go through that in a brief presentation next time. Forget the density concept of 0.17 or 3,000. We'll come to that, but we'll go through the table to show you that if you put all those parameters into that box, it will require a flow of 709 GPM at 51 PSI. Now there's going to be some, and that's only at where the design area ends. Of course, there's additional friction loss to get that water from the street to that design area. And in this case, they're flowing 710 GPM through 600 feet of 6-inch line. There's a 12 PSI loss. Next presentation, I'll show you how to do it. Very, very simple. Elevation, remember it's 18 feet off the ground. The water's got to go uphill. So that means there's a pressure loss due to that. And I'll explain how to do that. And so when you add the numbers in the box, plus the pressure loss going through the piping, plus the elevation, you end up with the demand at the riser of 710 GPM at 71 PSI. Let's punch in all that information we received in the prior example to see where they came up with 709 at 51 PSI. It's a wet system. It's an ordinary hazard 235. It was a center-fed 8-head branch line system. The lines were 12 feet across, apart on center. Head spacing 10 feet, 0.17 for the density. Leave that alone for right now. And the demand for the area within with the sprinklers that will activate is 709 GPM at 51 PSI. Very, very straightforward and simple. So for those people that know what density means, that know what different occupancy requirements would be, you're good to go. You should be able to sketch a system out, understand that it's a pipe schedule system, use these tables, and come up with some estimates as to whether or not the sprinkler system is adequate. Of course, there's a water supply component to that, which we will discuss, but you've got most of what you need. For those that aren't aware of all that information, I'll extend this out, so we'll be covering some other issues here that'll kind of make this more clear. Now, along with that AXA information, there's another source. It's loss prevention data 2-76. It's factory mutual pipe schedule sprinkler system demand tables. 56 pages of just what you saw on that one page with just about every combination you can imagine. The problem is that I've never been able to find it anywhere. I have it. This is from November 1977, so it's old, and I just have never seen this in online. If you're working with someone's mentoring you, especially if they're older, you might want to ask if they have this document, and if you could print it up, get a copy of it. It's a nice piece of information to have. I just haven't used it for the calculations because I don't think you're going to be able to find it. This is more of the same, FM 2-77, more recent, 1982, but still pretty old stuff. This is shorter document, I think it's 15 or 16 pages, has that same grid pattern, but also has developed K ratings for different branch sizes. I don't know if we'll ever get into that, but if you're familiar with that concept of an orifice, it's really kind of nice information to have. Again, ask for that if you're being mentored, if you're around someone that might be older, that might have this in hard copy, find and nicely ask them if a copy can be made. So for the next video, what we will do is learn how to calculate losses for elevation and losses for flow. Losses for elevation are very simple. It's just a multiplication factor and we're done. Flow losses will be done either through a calculator that I have, a handheld calculator, or a pamphlet, which can easily be, I have a NFPA pamphlet, but you can easily obtain something online that will give you friction losses for flow through piping. We'll run a number of examples, and possibly if I can find a site where I could actually go out and show you me sketching out a sprinkler system, that would be really great. The big boxes, for instance, usually have grid systems. They have beefy new systems. I'm really looking for a tree system, an older pipe schedule tree system, so that this might be hard to find. As I said before, if you have any background in any exposure to sprinkler systems, you should at this point be able to run some pretty fast estimates based on what I've given you. For the rest of you, what we'll do is these elevation and flow losses, discuss design area and density, which is very important, and I'll discuss K factors, as we're going to need to be able to back into some storage systems using this K factor when we don't have a hydraulic placard available. That shouldn't be too often, but it will come up. So any questions, by all means, post them, and I'll see you next month. Bye now.